All right, section 2 of chapter 7. This is video number 2 of part 2 of section 2. What? Anyways, we're continuing our discussion on how do you simplify a radical expression. Now, before we get into some more details today with this video, let me give you a stroll down memory lane of Algebra 1. But the question up here is, how do you add and subtract radicals? Well, first, let me again go back to Algebra 1 and even the beginning of Algebra 2 when we talked about adding like terms. These guys right here, 2x to the third, plus 4x to the 8th are not like terms. So you could not combine them. I don't care what you wanted to try to do, you can't do it. Now, how can I change that though? Well, if this happened to be x to the 8th power here, and I just take that 3 and make it an 8, how clever is that? Now we're talking same base, same exponent, so the parts are the same, so therefore we have like terms. And remember, when you combine these, because now you can, the base doesn't change, it stays x to the 8th power. But what does change? Well, you can actually take the coefficients and add those things together. You can combine those and add them up and get 6x to the 8th power. That is the final answer. You do nothing with the exponents. The 8 and the 8 doesn't change to 16. You don't do anything with it. That's adding like terms. Well, guys, if you remember that rule, it's going to be very simple when you add or subtract radicals, because over here I have 2 root 3. I have 4 root 3. The roots are the same. They come from the same tree, if you will. The roots are the same. So since the like radical parts are here, you can take these and combine them together just like you do with this. The root 3 stays exactly root 3. The base doesn't change. Just like it did over here with x to the 8th and x to the 8th, the root 3 stays root 3 and stays root 3. And similarly, that was weird, the 2 and the 4, when I combine them over here to the left, the same thing happens here. The 2 and the 4, I combine them. It's exactly the same concept. So I would get 6 root 3. That right there, woo, is your final answer. It's exactly how you do it. Now a couple examples look like this. Well, notice I have like radical parts. I got the square root of 7, and I got the square root of 7. Awesome. So what do? I take these guys right there, the coefficients of the radicals, and I combine them. So 5 minus 3, when I do that, I'll put that right here, 5 minus 3 gives me equals 2 root 7. So when I take the 5 minus 3, that gives me 2, so these guys together gives me that 2, and the root 7 just stays root 7. Wonderful. Well, this one here, I got the 5th root of 22, I got the 5th root of 22. They're like radical parts. So I can take the coefficients, the 6 and the 9, and combine them together. And I get, 15, 5th root of 22. So I take the 6 and the 9, I can put them together, 6 plus 9. I don't multiply, it's addition. And I get 15. 5th root 22 stays the same base. And last one, negative 5. Ooh, check this out. Well, I have root 3 of x, I have root 3 of x. So those things are the same. Therefore, I can combine them and take the negative 5 and the 2 and put them together. And what does that give me? It gives me negative 3 root 3 of x. And that's your final answer. There's nothing else you can do it. So very simple with adding and subtracting radicals in that regard. Now, let's lead into something else. What you're going to see now is directions you're going to say simplify the expression, and they look a little goofy. You got square root of a cube root of 5. You got the 6th root of the cube root of x, that's squared. What? I got the cube root of the square root of something that's raised to the 6th power. This is crazy. Well, let's do these. Let me move these guys out of the way. I think I can do this. I'll move this guy over here. I'll move this guy over here. And I'll move this guy here. All 3 of these examples most definitely need to go in your notes. So here's how you do it. Well, I'm going to take this thing and I'm going to rewrite it. Something of which you already know. So I'm going to take this guy. I'm going to keep this thing into a cube root of 5, but I'm going to take the square root and I'm going to write it as this. You'll see, and it'll make complete sense. It's the cube root of 5, but all of that is being raised to the 1/2 power. Why 1/2? Because that's what square root is. So I just took, I'll highlight it, I just took this thing right here, that square root, and I wrote it as 1/2. Now, I'm going to keep going and rewriting. This is, by the way, why section 1 was extremely important. I told you that in class. Now I'm going to take this cube root and I'm going to rewrite it. So the base, weird, The base is 5, so I'm going to take that 5, and I'm going to raise that 5 to the 1/3 power. That's 1/3 power. Lovely. So what I did again, I took this cube root, and now I rewrote it as the 1/3 power. And I still have all of this stuff right there, which is now all of this stuff right there. All of that's still raised. Back up a second, sorry. All of that's still raised, all of it, to the 1/2 power. Wow. Now you're going to say, why did you rewrite all that? Because what I'm doing is I'm simplifying this entire expression right here. So I had to kind of use my rule to rewrite it into rational exponents, So what I'm looking at, the power of a power. So now I can kind of go backwards, if you will, or keep going, whichever one you're looking at, it doesn't matter, and use my power of a power rule and take 1/2 times 1/3, which gives me 5 to the 1/6 power. Awesome. By the way, that right there is your final answer. That is simplified as much as possible. If you want to write it in radical notation form, it is the 6th root of 5. So there is an example. Phenomenal. Let's do one of the other two because I think you get the idea. Let's do one of the other two. So I pulled this one over here. What it is, it's the 6th root of all of this craziness in here, the cube root of x, but all that's being squared. Well, let's take our rule and rewrite this thing right here, this thing that's in the square, that guy. Let's rewrite that with the 6th root as a rational exponent. And here's what I mean by that. I'm going to take this thing, I'll write it as, well, equals the cube root of x, all that's squared. That whole thing, however, now, since I can take this thing, the 6th root, and I'll write that right up here, I can write the 6th root as this, 1/6 power. That's the 6th root. So now let's keep on going. Let's rewrite this thing, the cube root of x squared, as a rational exponent. So this thing right here, the cube root of x squared, would be base of x. The power is 2, and the root is 3. So this thing underlined in parentheses, all of that, right there, all of it, in these big parentheses, is x to the 2/3 power. That's cool, but don't forget, I still have then all of that raised to the 1/6 power. Ooh, yeah. So now what do? Well, apply the rule, the product of power rule, or the power of a power rule, sorry. So I take and I distribute, I multiply the 2/3 to the 1/6. Well, that means I get 2 on the numerator, and I get 18 in the denominator. Lovely. So what I'm looking at is x to the 2/18 power. Now, if you stop there, good try, my friends, but you have to take that and simplify it down to x to the 1/9 power. Because you can take this fraction, 2/18, and reduce it down to 1/9. So what's my final answer? This right here. Or, if you want to write into radical notation, it's the 9th root of x. Either one of those is perfectly fine. So there's that example. So what I decided to do is I actually pulled a third example up here for you. So this guy right here. And you see I already worked it out. So this thing here, I'd rewrite it as the 1/3 power, the 1/3 rational exponent, square root of y to the 6th. This whole thing in here, I just raise it to the 1/3 power, 1/3, because it's the 3rd root. And then I took this thing, as we've done before, since there's a 2 in there, that guy there goes to 6/2. I multiply these exponents, and I actually get 6/6, which is cool, which just gives me y. Oddly enough, this whole goofy thing this whole goofy thing there in green, that thing went down to, simplified the whole way down, to just y. How awesome is that? So let me now show you guys how you can take this idea that we just talked about and apply it to more complex questions, of which we're really getting to in the last part of this section. So wow, how do I take the 4th root of 16, x to the 12th, y to the 4th, z to the 2nd? What is the deal with that? And simplify it. Well, my friends, we're going to do it the same way we just did. So let's take and rewrite this thing. Whoa, what is going on? Let's take and rewrite this thing as all of this stuff underneath the radical, all of that being raised to the 1/4 power. Why 1/4, Mater? Because it's the fourth root. So I get 16 x to the 12th power, y to the 4th power, and then z squared. So why would I do that? Because now when I rewrite this radical into rational exponent notation, now I can take and I can use the product of a power. It's a power of a product. That's what it is. The product of a power. Goodness. The power of a product rule where I take this 1/4 and I distribute it here. And I distribute it here. And I distribute it way over here. And I distribute it way over there. Don't forget, it still does go over there. Oh, yes. So that means I get 16 to the 1/4 power times x to the 12 times 1/4 power, which is actually 12 over 4, which reduces down to 3. Well, that's pretty cool. And then I have 1/4, oh, sorry, y to the 4th times 1/4, and that gives me 4 over 4, which just gives me y to the 1st power. That's pretty cool. And then I take z squared, so 1/4 times 2 gives me z to the, weird, it gives me 2 over 4 power, which gives me 1/2. Okay, well, let's keep on simplifying. Is there anything at all when I look at this that I can do? Well, x to the 3rd is pretty set. Nothing else I can do. Y to the 1st is pretty set. 16 to the 1/4 power is really the same thing as the 4th root if I kind of now rewrite it. 16 to the 4th power, 1/4 power is the same as the 4th root of 16. But wait, can I simplify that? The 4th root of 16, what number times itself 4 times gives me 16? Oh, that's 2. So this whole thing right there just pretty much simplifies down to a simple little 2. Lovely. So I have 2 and then x to the 3rd power. And this right here is just y to the 1st. And now what do I do with this guy? Well, z to the 1/2. There's nothing I can do other than just write it like this. It is the square root of z. That's what it is. Why square root? Because it's 1/2 power. So my final answer, as ugly as that is 2 x to the 3rd y square root of z. Weird, but there you go. And we're going to practice a few of those in class too, and you're going to see what happens with those guys. And what's cool, watch this. Here's another one that I was going to give you guys. I can get myself out of the way. Check this out. I was going to give you this one. What you should do is try that on your own and see what you get. Did you pause the video? I bet you probably did. This is it. I'm going to tell you the answer. I'm not going to show you how to do it, but this is the answer. You should probably pause it right now and see if you can work it out. This would go down to 8x squared y to the 4th power. That was what that guy right up there would simplify to. So, we'll see you in class. We're going to practice these things. Rock and roll. Later. Have a great night.